Hello and welcome. In this video we're going to take a look at this KENWOOD chef. It's been given to me by a friend who said that it produced black smoke and then stopped working. I plugged it in, fuse is okay, so basically we've got to get into the speed control and have a look, see what's going on with that. That's got something you don't see very often these days, a nice good quality MK plug on it. A little while since I've took one of these apart, and I have a feeling, from what I remember, that there's a circlip down here that I've got to take off. That's the one. Now all I'm going to do is just get this screwdriver underneath the circlip there, just ping it off a little bit, and so it doesn't escape, I'm just going to grab it with my side cutters. Now that's going to stop it coming back towards me. So now I should be able to withdraw that, grab the spring, and that should give me a bit more freedom on that. It does. Under here there's two crosshead screws. Let's whip them out. Now that'll take that mechanism out of the way. Then the cover will come down out the way. So this is the speed control. It turns on a switch there and it alters this mechanism here that goes up and down. Now straight away there's our fizz, there's our bang, there's our failure. Capacitor has gone pop, and I suspect that's a resistor across it there that's also gone with a bit of a pop. I need to find out what the value of that is, so I'm going to have a little bit of a look on the internet and see what that can tell me. I think realistically I'm going to replace both these capacitors. I might replace the track as a matter of course. I have tried resetting that, that's made no difference. So it looks like there's 4 wires going down to the motor. So is this 2 brushes and 2 armatures, or is this part of the speed control? I'm not entirely sure. I'm going to now see if I can find an exploded diagram for this. Have a look at what some of these components are, but I'm going to stick my nose out and say that this capacitor here has gone pop. That's the failure. That's what's caused the smoke, and potentially this is part of the speed control circuit, and that's what stopped it working. This is the circuit diagram for the European version of this, the 220, 250 to 250 volts. Here's our mains coming in here to a switch, etc. It goes through the field windings. Then we've got the pink here. We've got our resistor that's burnt out and our capacitor that's burnt out. Now I know it's the 56 ohm resistor that's burnt, because when I look at the image that we've got here, we can see there's a red brown resistor here that's not burnt out. That is the 220 ohm. And also when we look at the diagram itself, so we've got our capacitor here that's gone pop, which according to this is a there's 47.47, so that is the 0.047. I'm not sure what voltage it is, we'll have to get into it. And we're on a 56 ohm resistor. Now this is part of the actual speed control itself, because you've got the governor contact here that opens and closes, but without this resistor here it's not going to be able to put the power to the triac to turn the motor on. So that's why it's not working. It's purely and simply that resistor's cooked, that capacitor's gone bang, end of story. So maybe the capacitor went first, took the resistor out, or vice versa, I couldn't tell you. But that's the failure. So I think we need to try and find some parts out, possibly order some parts in. Just had a bit of a Google, and there is a repair kit for this that contains a set of brushes, a few other parts, both the capacitors, both the resistors, a new triac, some gearbox grease and a new belt. So I think realistically this is what I'm going to get, and we'll fit this to the machine to repair it. This is what Kenwood have sent us. There is instructions for the repair kit, 56 ohm resistor, 220, 2 capacitors and a triac, with a fitting kit, fittings instructions on how to do it. That bit there should bring the Kenwood back to life. We also have the service kit. This is going to tell us how to service the mechanical part of the machine and grease everything, lubricate everything, take the gearbox apart. And in our packet we get some new feet, a seal, some silicone seal, a belt, 2 lots of grease. One is the edible grease, one is the non-edible grease for the gearbox. And that's about it. So I'm going to put that side of things to one side for a bit, and let's take a look at the electronic side of it, as far as actually getting this machine back to life. And let's see what these instructions are like and what they tell us that we can and can't do. Move the 2 screws. Okay, so we're inside it already. So we have here their instructions. Shows you where the 2 capacitors go, the triac, a couple of resistors, all of which are in here. What kind of frustrates me is they provide brushes, but in these instructions there's no, they don't tell you how to change them. So we're going to probably have to do a bit of investigation. I suspect the motor's got to drop out from the top to access the brushes, but we'll have a look from underneath. So I'm going to adjust things around, grab a cup of tea, and then I'll be back. So as we can see, we've got 2 capacitors, that burnt out resistor. So I think what I'm going to do is I'm going to take these couple of cables off the motor and just try and give myself a bit more room. The first thing I'm going to do is just go in with my phone and just take a photo. And even in the instructions it suggests that you take lots of photos with your phone to give you a record of what you're doing. So first thing I'm going to do is, I feel that this red cable here is rather intrusive as far as seeing what's going on, along with this pink cable here. So I'm just going to pop in here and disconnect that one and that one. Okay, so very tight on that. That's very tight on that. It does suggest to take the wire off, but I'm trying to avoid that if I can. Can I take the incoming mains cable off easily? Not really. It's going to be much more hassle than it saves. I know why it says to take the mains cable off. It gives you the ability to move this around more. So there's a couple of, there's a connector block there. Oh, look at that. That's not best, is it? Now, I'm actually going to free the mains cable totally out, because as part of the refurbishment on this, I'm going to put a new mains cable on it with a moulded on plug. Okay. You've got to love the 1 litre got Volkswagen posse. With their blah, 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 blah. Right, okay, so this capacitor here is a mains filter. It is purely and simply straight across the mains side of things. So I think what I'm going to do with this is I'm going to come in and I'm going to go snippety doo-dah to take this one out because of the way that they're wrapped around. Then I can clean up this area and then we can put the new one in. Now, size wise, according to this, that is the 0.15 capacitor, which is going to be this one here. I don't know if you're able to read that. You can actually. It's 0.15, so we're going to put that one in. Sort of just try and decrud this as much as I can. You know what? That just dropped off quite nicely. So here's our new capacitor. It's a little bit smaller than the one that's come out physically. Nothing to be worried about because obviously these components are, this is a 1980s machine, so yeah, many years newer. Come in here and here, put some solder on it. And then I'm just tidying up with a very sharp pair of cutters designed for working on electronics. That's gone in really nice and tidy. Okay, let's see what we can get as far as tidying up this mess and getting up this excess solder off here. Quite a good chunk came off that. The same again. And here. Because all of this has got to come out. I'm just trying to remove a good quantity of the solder, just to make it a bit easier to disassemble it. So I'm not really concerned about trying to keep any of the components that have come out of this. So I'm actually going to just cut that resistor off here. We'll come in with the soldering iron here on the left. Warm that up, and I'm just going to unhook that. Yeah, okay, I'm happy that looks nice and clean. I'm now going to go for the other half of the resistor. Just hold it with a pair of cutters and try not to try not to cut. Yeah, easier said than done. Okay, so there's the one bit out. You're going to come out for me? Bit. One of those strange concepts with soldering, actually putting solder on to unsolder. Okay, so we've actually got a problem there. That's broken off. It's not a big problem because we've got a spare tab here, but it's something that we need to be aware of. Now, it looks like this one here, well we do know that this one here is just the two of them linked round. So we'll cut that off there to give us access to the other half of it. I've done unsoldered it a bit, let it get warm, cold. Then I can twist this round a bit more, work it out, and we can actually see the capacitor there that exploded. A really good failure. This is the back end of the switch, I think. Remember rightly? Looking at the diagram. Okay, that two bits of that's unhooked. Okay. So we want the triac out next. And cut that leg off. Some heat in there. There we go, there's the leg off the triac. There. Here's the resistor that we previously saw, and as you can see, that has absolutely fried itself. Now, one thing I'm going to note here is that is the one that's coming out size wise. That's the one that's going in. So that looks like that's a 1/4 watt or maybe a 1/2 watt. This looks like somewhere around a 3 watt or a 4 watt, so they put a much larger value of resistor in. So I'm guessing that that's probably a failure point on these, and Ken would have picked up on it and addressed it. Let's get this triac out of here. Ah, nice. It's held in with a nut and a bolt, just to make things a little bit more difficult. So at the moment I've got my finger on the back here, just holding the nut. I am going to drop it down. Now I don't know where it's gone. So just going to give it a touch of thermal paste there. I bent the legs out just to make things a little easier putting it together. And I've got a nut and bolt. Now it looks like actually the easiest thing to do is to bring your hand in from the back with the nut and bolt. Now I'm having a little bit of a game here, so I'm going to put this on its side. Get that lock nut on there. Probably not making the best video to watch at the moment, but hey ho. Okay, so that's actually got that started. It was a little awkward. Let's put it back the right way round. Okay, so I've got a nut and bolt on there. Can I get that to reach there if I do that? So what I'm actually going to do, I'm going to bend that tag up, bend that tag, and tighten this up in this position. so that we have half a chance. Long nose pliers on the back of there. Okay, so we need to make a connection to there, so let's bend that way. And we're just going to bend this up for a second, not too heavily, bend that way, bend that back round there, bend that over there, and now we've got our triac in place. So over this side, I'm actually going to refer to my colour photo rather than the black and white photo that I had there. No, okay. So it looks like this resistor here goes from there to there. Now because of the size differences, I'm just going to tuck this one up the top here. I'm going to put it onto here, and I'm also going to use a little bit of the extra leg length, and I'm going to solder it to the leg on the triac directly, just to make sure that I get a good connection. Let's start by soldering this to the switch, like that. Solder this to the connecting point, but I'm also going to solder that to there. So that way we know that that leg is joined to that resistor. Okay. That wants to be soldered onto here. Come on, pick it up. Thank you. That does want to join to here. Again, I'll make sure. So, next up, we have a capacitor and a resistor. So the capacitor runs from this terminal here at the bottom to the switch terminal. So I'm going to sort of try and sit it there. I'm going to wrap it round the switch terminal like that. Then I'm going to bring it down round here and over the top here, and this again will allow me to make a soldered joint to the actual leg on the triac as well as onto the block, just for good measures. So I'm just going to solder that, and I'm just going to make sure that's pushed down onto there, and you can see there we've actually got a joint onto the leg of the triac as well. So if there's been any movement in anything. Okay. And then we've got our resistor. Again, and I sort of just wrap it round, place it there like that. And we'll give all this lot on here a good application of solder between them. Just make sure they're both soldered on well. Let that go cold. Just give that a second or two because I've got that quite warm. Yep, there we go. Trim these two off tidy. Okay, they're both on there. This then goes round onto the triac. Again, for good measures. I'm going to push that down into place under there so it tucks under and it joins the triac. So when we put this solder on here, we've got some solder to the leg on the triac itself as well as to the joint. So there we've got the tray back in place, the capacitor, the resistor and the other capacitor. Now the final things we need to do is to put the 2 wires back on that we've took off. One I believe went up there, one went there. I'm just going to check the photograph I took. So the blue one went there, the red one went there. Sorry, the pink one went there, the red one went there. And feed that into there like that and hold it in place with a little flat bladed screwdriver. That way then I can ensure that it stays where I want it to be, which is down there. Got a bit of solder here. I've got it in place. I'm going to put the soldering iron on top of it, give it a glob of some solder, and then I'm going to hold it down with my screwdriver while the solder cools down. And then finally this red cable goes back here. There's a little bit more slack on this one. I'm just going to put a bit of fresh solder into here for good measures. Put that onto there. Pull it back off because I'm impatient. Let's try again. Okay, so now I'm in a situation where, all being well, if I put power back to the mixer, it should run. So let's give that a try. I'm just going to move around. Okay, let's see what we get. Stick the neutral in there, stick the phase in there, and make sure that's turned off. Close the door. So there we go, that's brought the actual mixer back to life. So what we'll go on to now is we'll flip it round. I'm not going to connect the mains cable back on yet because I feel that I'm going to have to take the motor out to do the brushes. So the next thing we're going to address, I think, is taking the top off to access the gearboxes and the worm drive, and we'll give that all lubricate as per the instructions and work out how to fit a set of brushes in this as well for good measures. But there we go, that's it fixed. That's actually the initial fault repaired. Now we'll go on and give it a service.